Installing a 70 amp fuse in a 100 amp rated fusible disconnect serving as the service disconnect for a new home or service change constitutes a violation of the National Electrical Code. The NEC mandates that the overcurrent protective device, whether a fuse or circuit breaker safeguarding a service disconnect, must be rated to handle the full ampacity of the service conductors. In the scenario presented, the service conductors are rated for 100 amps. Consequently, the fuse or circuit breaker must also possess a rating of 100 amps. Employing a fuse with a 70 amp rating is considered an undersized overcurrent protective device. This situation directly contravenes the stipulations outlined within the NEC. The fundamental principle is that the overcurrent protection must adequately safeguard the conductors against overloads and short circuits. Using a smaller fuse, even if the actual load is less than 70 amps, does not comply with the code requirements for service entrance equipment. The NEC sets minimum standards for safety, and these standards are based on the potential for future load increases or unforeseen events. An undersized fuse could lead to nuisance tripping, potentially interrupting power unnecessarily. More importantly, it might not provide adequate protection in the event of a fault, such as a short circuit. In a short circuit, the current can rise to extremely high levels very quickly. An undersized fuse might not react quickly enough to interrupt the circuit before damage occurs to the wiring or equipment. This could result in a fire or other hazardous situation. It is essential to adhere to the NEC guidelines to ensure the safety and reliability of electrical installations. Using the correct size fuse or circuit breaker is a critical aspect of electrical safety. Always consult the NEC and local electrical codes for specific requirements and guidance. Ignoring these codes can have serious consequences. The requirement for matching the overcurrent protection to the service conductor ampacity ensures that the electrical system can safely handle the anticipated load while providing adequate protection against faults. Choosing the correct fuse size for a service disconnect involves several considerations. Firstly, the ampacity of the service entrance conductors must be determined. This information is typically found on the conductor insulation. Secondly, the NEC specifies the minimum ampacity required for service entrance conductors based on the calculated load of the dwelling. Thirdly, the overcurrent protection device, whether a fuse or circuit breaker, must have an ampacity equal to or greater than the ampacity of the service entrance conductors, but not exceeding the ampacity of the busbar in the panel. It is important to note that the NEC permits the use of the next standard size overcurrent protection device in certain circumstances, but this is not applicable in this case since the goal is to purposefully undersize the fuse. The NEC specifies standard sizes for fuses and circuit breakers. For example, standard sizes include 15 amps, 20 amps, 25 amps, 30 amps, 35 amps, 40 amps, 45 amps, 50 amps, 60 amps, 70 amps, 80 amps, 90 amps, 100 amps, 110 amps, 125 amps, 150 amps, 175 amps, 200 amps, 225 amps, 250 amps, 300 amps, 350 amps, 400 amps, 450 amps, 500 amps, 600 amps, 700 amps, 800 amps, 1000 amps, 1200 amps, 1600 amps, 2000 amps, 2500 amps, 3000 amps, 4000 amps, 5000 amps, and 6000 amps. When selecting an overcurrent protection device, it is important to choose a device that is listed and labeled for the intended use. This ensures that the device has been tested and meets the applicable safety standards. The listing and labeling information is typically found on the device itself. It is also important to ensure that the overcurrent protection device is properly installed. This includes ensuring that the device is securely mounted and that the connections are properly tightened. Loose connections can cause overheating and lead to a fire. Regular inspection and maintenance of electrical equipment is essential for safety. This includes checking for signs of damage or wear, such as cracked insulation or loose connections. Any damaged or worn equipment should be replaced immediately. If there is any doubt about the proper installation or maintenance of electrical equipment, a qualified electrician should be consulted. Attempting to perform electrical work without the necessary knowledge and experience can be dangerous. It is always best to err on the side of caution and seek professional help. The consequences of ignoring electrical codes and safety practices can be severe, including electrical shock, fire, and even death. It is important to take electrical safety seriously and to follow all applicable codes and regulations. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect the latest advancements in technology and safety practices. The NEC is adopted by many jurisdictions throughout the United States and serves as the basis for local electrical codes. Familiarizing yourself with the NEC and your local electrical codes is essential for anyone involved in electrical work. There are many resources available to help you learn about electrical safety and the NEC. These resources include books, websites, and training courses. The National Fire Protection Association, or NFPA, is the organization that develops and publishes the NEC. The NFPA website provides access to the NEC and other electrical safety resources. Many community colleges and vocational schools offer courses in electrical wiring and safety. These courses can provide valuable training for anyone interested in pursuing a career in the electrical field. Always remember that electrical work can be dangerous. If you are not comfortable performing a task, it is best to seek professional help. A qualified electrician has the knowledge and experience to safely and effectively perform electrical work. By following electrical codes and safety practices, you can help to protect yourself and others from electrical hazards. The specific section of the NEC that addresses overcurrent protection for service conductors is Article 230. Part E of Article 230 covers service equipment overcurrent protection. This section outlines the requirements for the rating and location of overcurrent devices used to protect service conductors. In addition to Article 230, other articles in the NEC may also be relevant to the selection and installation of overcurrent protection devices. For example, Article 240 covers overcurrent protection in general, and Article 310 covers conductors for general wiring. It is important to consult all applicable articles of the NEC when performing electrical work. The NEC is not a static document. It is constantly evolving to reflect changes in technology and safety practices. The NEC is updated every 3 years, and it is important to stay up to date on the latest changes. The NEC is available for purchase from the NFPA and other vendors. It is also available online through various subscription services. In addition to the NEC, many jurisdictions have their own local electrical codes. These local codes may be more stringent than the NEC. It is important to be familiar with both the NEC and your local electrical codes when performing electrical work. The local electrical inspector is responsible for enforcing the electrical codes. The inspector will review your plans and inspect your work to ensure that it complies with the codes. It is important to cooperate with the electrical inspector and to address any concerns that they may have. The electrical permit is a document that authorizes you to perform electrical work. You typically need to obtain an electrical permit before starting any electrical work. The electrical permit process varies depending on the jurisdiction. It is important to check with your local building department to determine the requirements for obtaining an electrical permit. Performing electrical work without a permit can result in fines and penalties. It can also void your insurance coverage. When selecting overcurrent protection devices, it is important to consider the interrupting rating of the device. The interrupting rating is the maximum amount of fault current that the device can safely interrupt. The interrupting rating must be greater than the available fault current at the point of installation. The available fault current is the amount of current that would flow in the event of a short circuit. The available fault current can be calculated using various methods. It is important to consult with a qualified electrician to determine the available fault current at your location. Using an overcurrent protection device with an inadequate interrupting rating can result in a catastrophic failure in the event of a short circuit. This can lead to a fire or other hazardous situation. There are two main types of overcurrent protection devices: fuses and circuit breakers. Fuses are one-time use devices that melt when the current exceeds a certain level. Circuit breakers are reusable devices that trip when the current exceeds a certain level. Circuit breakers can be reset after they trip. The choice between fuses and circuit breakers depends on the application. Fuses are typically used in applications where high interrupting ratings are required. Circuit breakers are typically used in applications where convenience and reseatability are important. Both fuses and circuit breakers must be properly sized and installed to provide adequate overcurrent protection. It is important to consult with a qualified electrician to determine the best type of overcurrent protection device for your application. The ampacity of a conductor is the maximum amount of current that the conductor can safely carry. The ampacity of a conductor is determined by its size, material, and insulation. The NEC provides tables that list the ampacities of various types of conductors. It is important to select conductors with an ampacity that is sufficient for the load that they will be carrying. Using undersized conductors can result in overheating and a fire. The voltage drop is the decrease in voltage that occurs along a conductor. Voltage drop is caused by the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends that the voltage drop in branch circuits not exceed 3% and that the voltage drop in feeders not exceed 5%. To minimize voltage drop, it is important to use conductors that are large enough for the load that they will be carrying. The grounding system is an important part of an electrical system. The grounding system provides a path for fault current to flow back to the source. This helps to protect people from electrical shock. The grounding system must be properly installed and maintained to be effective. The NEC provides detailed requirements for grounding systems. It is important to consult with a qualified electrician to ensure that your grounding system is properly installed. Electrical safety is everyone's responsibility. By following electrical codes and safety practices, you can help to protect yourself and others from electrical hazards. If you are not comfortable performing a task, it is best to seek professional help. A qualified electrician has the knowledge and experience to safely and effectively perform electrical work. The service disconnect is the main switch or breaker that disconnects all power to a building or structure. It is typically located near the point where the service conductors enter the building. The service disconnect must be readily accessible and clearly labeled. The purpose of the service disconnect is to allow for quick and easy shutoff of power in the event of an emergency. The service disconnect must be rated for the ampacity of the service conductors. It must also be capable of interrupting the maximum available fault current. The service conductors are the conductors that run from the utility company's transformer to the service disconnect. The service conductors must be sized according to the load that they will be carrying. The service conductors must also be protected from overcurrent. The service entrance is the point where the service conductors enter the building. The service entrance must be properly sealed to prevent water and pests from entering the building. The service entrance must also be protected from physical damage. The meter is a device that measures the amount of electricity that is being used. The meter is typically located near the service entrance. The meter is owned and maintained by the utility company. The panel board, also known as a breaker box or load center, is a cabinet that contains circuit breakers or fuses. The panel board distributes electricity to the various branch circuits in the building. The panel board must be properly sized for the load that it will be carrying. The panel board must also be protected from overcurrent. Branch circuits are the individual circuits that supply power to lights, appliances, and other electrical equipment. Branch circuits must be properly sized for the load that they will be carrying. Branch circuits must also be protected from overcurrent. Receptacles, also known as outlets, are devices that provide a point of connection for electrical equipment. Receptacles must be properly grounded. Receptacles must also be protected by a ground fault circuit interrupter, or GFCI, in certain locations. GFCI protection is required in wet locations, such as bathrooms and kitchens. Lighting fixtures are devices that provide illumination. Lighting fixtures must be properly installed and grounded. Lighting fixtures must also be suitable for the environment in which they are installed. Appliances are electrical devices that perform a specific function, such as cooking or washing clothes. Appliances must be properly installed and grounded. Appliances must also be protected by a dedicated circuit. Electrical equipment is any equipment that uses electricity. Electrical equipment must be properly installed and grounded. Electrical equipment must also be protected from overcurrent. Overcurrent is a condition in which the current in a circuit exceeds the ampacity of the conductors. Overcurrent can be caused by a short circuit, an overload, or a ground fault. Overcurrent can damage electrical equipment and cause a fire. Overcurrent protection devices are devices that protect electrical circuits from overcurrent. Overcurrent protection devices include fuses and circuit breakers. Fuses are one-time use devices that melt when the current exceeds a certain level. Circuit breakers are reusable devices that trip when the current exceeds a certain level. Ground fault is a condition in which current flows to ground through an unintended path. Ground faults can be caused by damaged insulation or faulty equipment. Ground faults can be dangerous because they can cause electrical shock. Ground fault circuit interrupters, or GFCIs, are devices that protect people from electrical shock caused by ground faults. GFCIs detect ground faults and quickly interrupt the flow of electricity. Electrical shock is a dangerous condition that can occur when a person comes into contact with electricity. Electrical shock can cause burns, muscle spasms, and even death. Electrical fire is a fire that is caused by electricity. Electrical fires can be caused by short circuits, overloads, or ground faults. Electrical fires can be very dangerous because they can spread quickly and be difficult to extinguish. Always consult with a qualified electrician.